So unit 2, we started talking about radicals, so your square roots, cube roots, fourth roots, all of that. We did some of these equations in unit 2 and some in 3A once you had more skills, but I'm going to talk about anything that deals with a radical equation here to really keep all that information in one spot. What we originally talked about was these two basic ones you have right here. For this one on the left, it is very similar to what we've talked about with recent problems. If you have the square root of some number equals the square root of some other number, those two numbers have to be the same or this equation doesn't work. So what we said is we could really just set both equal and solve it. So I'm going to have 3b equals negative 27, and you get b equals negative 9. Now, we did talk about the fact that you have to check your answers in these problems for a few different reasons. One is that anytime you square both sides, which is technically what we did and what we will actively do in other problems, you open yourself up to extraneous solutions. And the other thing is that under your radical has to be positive or it doesn't work. So we have to make sure both those things are true. So when I plug in negative 9, it looks like this. And I'm going to do both these sets of math. So negative 8 plus negative 9, minus negative 9, which is really plus, gives me just the square root of 1. On the right side, 2 times negative 9 plus 19 gives me also the square root of 1. Those are positive and they're the same. So that means negative 9 works. This second type, where you have only one radical instead of two, you do need to isolate that radical first. So I'm going to divide by negative 8, and you get 10 equals the square root of 16r plus 4. And then we have to undo this radical a little more actively than last time. To undo a square root, you have to square both sides. On the left-hand side, you don't have a root, so you're actually going to square it. On the right-hand side, you're going to remember that the square and the square root cancel, and you just get what's underneath. Then you're going to solve this. So minus 4 gives you 96 equals 16r. And 96 divided by 16 gives me 6. Now again, you do have to check this. You can check anywhere before you squared it. So I'm going to check after I divided by that negative 8, just because it's a little cleaner. Doing the number under the radical, I get square root of 100, which does in fact equal 10. So that is a solution. In Unit 3A, we took it a step further and did a slightly more complicated version of the same thing that I'll talk you through here. You still need to isolate this radical first. So I'm going to add 5 over, so you get x plus 5 equals the square root of 6x plus 70. And then we still need to square both sides. On the left, it stays straightforward. But on the right, you need to remember that you are squaring this whole binomial. So you need to write x plus 5 twice and actually multiply that all the way out. What you should get once you do that and combine some like terms is x squared plus 10x plus 25. The reason we did this in Unit 3 at the original time was because you didn't know how to solve a quadratic yet in Unit 2. Since you have an x squared, we need to set this all equal to 0, so I'm going to move that 6x and that 70 over. And you end up getting x squared plus 4x minus 45 that now we need to factor. Multiplying to negative 45 and adding to 4 is going to be 9 and negative 5. Just to make sure we have a review of factoring, I'll write this all the way out for you. There will be a whole lot of factoring in Unit 3's video, though, as well. Once you get to this point, x minus 5 equals 0 tells you that x would equal 5, and x plus 9 equals 0 gives you x equals negative 9. But we cannot just believe both, we have to actually check it. I am going to check at this yellow line where I had already moved it. Again, you can check anywhere before you squared it. If I plug in the 5, and do this math to make sure it works. 5 plus 5 is 10. 6 times 5 is 30, plus 70 gives me 100. Square root of 100 is 10, so 5 works. And then I need to check negative 9. So if I plug it in, I have negative 9 plus 5 equals the square root of 6 times now negative 9 plus 70. 6 times negative 9 is negative 54 plus 70 gives you 16. Square root of 16 is 4, but on the other side I have a negative 4. Those numbers are not the same, so negative 9 is not an answer, and my only solution is 5. Cube roots were similar, so we'll talk through this one. Again, like before, you want to first isolate that radical. So I'm going to subtract 2, divide by 3. But now I want to undo a cube root. And to undo a cube root, I need to cube both sides. The cube and the cube root will cancel. And on the right side, I'm going to have to actually do it. But then you solve it and you get x equals 220. Now, cubing both sides does not give you the same issues as squaring both sides, but it is still good practice to check this. I'm going to check it here because that's going to be the cleanest spot to check it. Again, you have to check it before you raise both sides to a power, and as long as you do that, that's fine. 220 minus 4 is 216. Cube root of 216 is 6, so this does check. Again, I expected it to because it was a cube root, but I will tell you to always check if you're not going to remember when to check and when not. It's always good practice to check. Number 7 looks different, but what I will remind you, this 1/4 exponent is the exact same as the 4th root of 2x minus 7. So anytime you have a rational exponent, just rewrite that as a radical instead. And then again, we want to isolate our radical. So 7 times the 4th root of 2x minus 7 equals negative 28. And then the 4th root of 2x minus 7 equals negative 4. To undo a 4th root, much like before, you are now going to raise both sides to the 4th. Negative 4 to the 4th power is going to be 256. And the left-hand side just cancels. When you go ahead and solve that, you get 131.5. But again, we do have to check, and it is super important to check when it is an even root, like this one was. I always check right before I raised it to a power. Minus 7, and I'm going to see if that equals negative 4. When I do 2 times 131.5 plus or minus 7, I get the 4th root of 256. And the 4th root of 256 is a positive 4. So again, positive 4 does not equal negative 4. So this is not an answer. In this case, that gives me no solution. What we also need to talk about a little bit is what you do with other rational exponents. And again, these we didn't talk about in that chapter because we knew we needed a few more skills. I'm going to move this too because I can, because that's easy to do. And I'm also going to rewrite this. This is the square root of r plus 7 cubed. And then we need to undo both these things. And this is what we have talked about throughout the year. Undoing the square root, you're going to square both sides. 729 squared is going to be huge, so I'm just going to leave that for now. And here we have a cube that we can undo. We can cube root both sides. The cube and cube root will cancel, and you get r plus 7. And then on the left-hand side, we can actually evaluate this. If we type in our calculator the cube root of 729 and then square it, you should get 81. Cube root of 729 is 9. Squared is 81. And then we're going to solve. 81 minus 7 gives me r equals 74. We do need to check, like always. I'm going to check right here, because again, that's the neatest place. 729 equals the square root of 74 plus 7 cubed. And this is really just your calculator's job. If you type this right-hand side correctly into your calculator, it does give you 729. So 74 is my correct answer. One more that looks like that, just for good measure. Again, I'm going to isolate this parentheses. So I'm going to divide by 2. Gives me 16 on the right-hand side. And I'm going to rewrite this rational exponent. The 5 on the denominator tells me it's the 5th root of x plus 2 squared. And then we're going to undo both pieces. The 5th root, to undo that, we're going to raise both sides to the 5th. Again, on the left, it's just going to cancel. And on the right, I'm going to leave it as 16 to the 5th because that's huge. Then to undo this squared, I need to square root both sides. On the left, it'll cancel and just give me x plus 2. On the right, remember you can do this root if you want to. Square root of 16 is 4. But because a square rooted, one thing we talked about in Unit 3a is you have to have a plus or minus there. So it's plus or minus 4 because you get 2 answers from any quadratic, which is technically what that is. Then I'm going to do 4 to the 5th, which I believe is 1024. Yes, this is plus or minus 1024 equals x plus 2. This is 2 numbers. Oopsies. So I do need to split it into 2 problems. I have x plus 2 equals 1024, and I have x plus 2 equals negative 1024. And you get x equals 1022 and equals negative 1026. Again, we do need to check these. Since it was a 5th root, I don't anticipate any problems, but it is always good practice. And with these, again, I'll fill them both in for you real quick. As long as you type them correct in your calculator, both of them do check out. Do make sure that you're doing that addition, squaring it, and then 5th rooting it. And technically the 5th root and the squared you can do in either order. Last thing we're going to talk about, like we did last time, is a little bit of inverses again. And so I'll do each of these a different way to make sure you see, but this is really pulling back to the Unit 1 video, so if you haven't watched that yet, make sure you do for a bigger recap. To state if they were inverses or not, we had 2 methods. One where you just solve one equation for the other, and one where you plug it in. So I'm going to try this one by plugging it in. I'm going to do f of g of x. So I'm going to plug... I'm actually going to go the other way because plugging that in looks really ugly. And you are welcome to make that call as you go through and pick your type. So I'm going to plug f into g. And when I do that, I get negative 4 minus the cube root of 4 times negative 2 times x plus 2 cubed all over 2. Doing this math, 4 times negative 2, that gives me negative 8. And where this is helpful, I can cube root both of these things. The cube root of negative 8 is just negative 2. Cube root of x plus 2 cubed is just x plus 2. And then it just becomes doing some of this math. This negative times a negative 2 is really plus 2. I'm going to distribute this negative 2, so it's negative 4 plus 2x plus 4 all over 2. These 4's cancel. 2x over 2 gives me just x, which is what we talked about last time as being the prerequisite. Again, that is not the only way to do it, but that's one way to solve that problem. The other way would be the way I'll show you here, where you take maybe one of them. So I'm going to take this f, and I'm going to switch my variables. So I'm going to do n equals the cube root of f plus 1 over 2. And I'm going to now solve for f. First thing I would do is cube both sides. And then I need to get this f by itself. So I would multiply by 2. And subtract 1. So the inverse of this first equation f is 2n cubed minus 1. Then what I'm checking is if these two match. They don't, so these are not inverses. Do make sure to make that distinction at the end. So I may have said it, but I didn't write it. So yes, these first ones are inverses. To actually find the inverse, like on this one, we are going to have to do it that second way that I did. This one looks more specifically like the first equation to give you an idea of what that would look like. First thing I would do is flip these variables. And now we need to solve for h. So I would multiply by 2 to get that denominator taken care of. And then you need to isolate your radical. So I will add 6. And this is where we will actually cancel the radical, cube root. So I'm going to cube both sides. I do not expect you to FOIL that all the way out. That's not the point of these exercises. So your answers won't have that FOILed out. Don't stress about that. And then I'm going to divide by 4. So my inverse of this equation is 2x plus 6 cubed, all divided by 4.